In this next section of the video, I want to talk about databases and GIS. Some people describe GISs as a glorified database or a database that uses spatial information. And to understand why this is the case, just look at the definition of a database. A database is a collection of data files that is structured or organized to facilitate data storage, manipulation, and retrieval. So it sounds to me exactly like a GIS without that, of course, the emphasis then on spatial data. With GIS, we also talk a lot about database management systems, and these are software packages that perform database functions. So I wanted to get familiar with databases, talk about a few key concepts or vocabulary you may hear in database terminology. Some of these we've discussed, and some of them will sound familiar from reading and working with the GIS tutorial. So a database is composed of a set of tables, and these tables are called relations. All right, so think of your spreadsheet now, or your attribute table. Within these attribute tables are records, or they're sometimes called rows in the table, and these are in database terms called tuples. In your attribute tables, again imagining you have fields or columns, and again in databases, these are called domains. So basically, here's an example of how a relational data model works. Each record in your attribute table represents a logical entity. In my example here, students are the logical entity, right? Kermit the Frog, Miss Piggy, Fozzie Bear, and Animal, 4 students. Each field, each variable you might think of, variable name, represents an attribute or a property of the local entity. So the main record, each row is a student, and each field, each variable, is an attribute of the student. So the student ID number, the student's last name, the student's first name, the student's grade, and the student's class. Each table in a relational data model has a primary key, or what we call a unique identifier. So it's one field, or it could be a combination of fields, that has a unique value for each and every record in the table. So for this example, ID is the primary key or unique identifier. Because it is unique to each student, it won't repeat. If we add more students down there, they will have different ID numbers. An ID variable is very common to use in all relational database models. And if you think about it, it makes sense. Last names are often repeat. My last name is Jordan, so in most databases there's lots of Jordans, so that doesn't serve well as a unique identifier. First names, of course, often repeat. Doesn't make them unique identifiers. Here we see grades repeat and classes repeat, so those can't be unique identifiers. The creation of an ID variable, creation of a unique identifier, is really important. And this makes a lot of sense to us living in a developed democracy, each having a social security number, right? So that's our unique ID for the federal government. We also have driver's license numbers for the state of Florida. Those are our unique ID for the state of Florida. Other unique IDs we have include our barcodes that we use. When we have a card, we take it to Best Buy, to CVS, to the pharmacy, where it scans in your card number. That's your unique identifier in the database. Of course, your credit card, an important unique identifier. You don't want to overlap at all or for anyone to find out. Right, so this is you in a database, us in a database world, and GIS works the same way. There needs to be a unique identifier to make these relational data models work. Okay, so within the relational data model, tables can be related, joined, or linked together based on their keys. And this example, which I'll begin now and explain more in detail than the last video, is that we have two primary keys in each one, in which we can take 2 data sets, right? One on the students, their classes and grades, and another on classes and instructor and number of students, and join them together to create one full table, where data in this one informs data into this table. Okay? So we'll look at this more next time.